Hi, this is Nick FV, and in this video we're going to add rolling joints to our structure. What I mean by that is, for example, if you have a pinned joint, that joint cannot move at all in the X or Y direction. It is literally pinned in place. Now, for example, if you have a link to another joint over here, and it is a rolling joint, this type of fixture allows the joint to move in the X axis. Now, for example, you could have another link connected to another joint that could restrict the motion into the Y axis. So you could have different types of rolling joints. And what this does is that it still fixes your truss or structure in place, but it allows it to expand and contract based on the tension or compression inside the system. And so to do this, we're going to have to take advantage of vector projection. For example, if I have a vector A like this and a vector B like this, I can project B onto A like this. And what this allows me to do is that I can fix the momentum or the velocity of each of these joints within their respective rolling planes. In the SMATH NPM package, the Vec3 class has this handy project onto function, which we're going to be using to create these rolling joints. So let's get started. Alright, so we're in the project directory now. Let's start by making sure all of our dependencies are installed by running bun I. And now we can build the project in development mode using bun dev. Now when I refresh this panel over here and I click on it to focus it, it runs the simulation. So what we're going to be doing here is converting this joint over here into a rolling joint where it can roll along the horizontal plane. So over in my joint class, I have this pinned boolean. So we're going to create something similar, except it will be a Vec3, which takes in the plane that the joint is being rolled. So what I did here is I check if a roll direction has been set, and if it is, I set the momentum equal to the projection onto this roll direction. So let's try this out. I'm going to go back to the index file, and you can see how I've pinned this joint and this joint. So I'm going to unpin this one. So if I run this simulation, we'll see it swing around like this. But instead, I'm going to make this roll along the x-axis. So how I could do that is give it a new Vec3 in the 1, 0 direction. And now we can see that it rolls a little bit along that x-axis. And just to make it more visually distinct, I'm going to color this in with gray. Alright, so now if I rerun that, now we can see that this joint is colored in gray, and this one is still black. If you're a crazy animal, you can also build your bridge along a 45-degree angle slope by setting this Vec3 to 1, 1 and rerunning your simulation. Now you can see that your bridge is barely holding itself together. And that's all that there is for this video. Thanks for watching, and I'll see you in the next one.